I'm going to show you, after a lot of looking up, I finally figured out what they were doing. Some of it I can't avoid because they were doing it inside the software. So the degrees of freedom thing, I couldn't do. You know, the ones where they say it's 37, where we would take the smaller of the two. That I couldn't avoid or find a workaround for, but the rest I did. So I'm hopefully going to show you what that is. And so that it won't be such a, you know, leave a bad taste in your mouth that the last thing, why can't the last thing work? So hopefully that'll work for you. And what else? So most of it is done. The difference now is just degrees of freedom, which I can't avoid, really. But I've made the answers tolerable enough that it shouldn't matter. So I put a wiggle room on the rounding off, so that should cope with that. And secondly, I made those questions 0 points, so they can't affect your grade, and then we rescheduled it, rescored it. So that takes care of the I'm losing points for no fault of my own.
I appreciate that. Thank you.
Yeah, this is the first time we've used this textbook. We've used WebAssign before, but we used a different textbook. So in a lot of ways, you don't know what you're going to meet until you've met it, and then you suddenly realize that, you know, everything's perfect. So it'll make my job a little bit easier the next time because I know this is coming, so I will adjust accordingly. But most of the time, it's been pretty decent. I think this textbook's been pretty good most of the time. I think at the end, it's hit a little snag. I think a lot of the time the data has worked fine. So I don't feel I need to change the textbook for the next stats class. Was there other issues in WebAssign? Because I'm seeing it from my perspective, not from the students. Were there other things in WebAssign that you just didn't feel that they were doing a great job, or they made it harder than it was, or whatever? Nothing comes to mind? That's good.
Questions in 13A with when it was asking about the p-values and stuff and just using salt. A lot of the times it would say it was correct and stuff, but some of the times it wasn't, and so I didn't know like what I was doing wrong.
What went wrong? What's 13A about again? Is that a single proportion hypothesis test?
It's testing a hypothesis about a single mean, and it was just I think it was question number 6, and I couldn't seem to get the right p-value.
Question 6 in what section again? 13.1, did you say? 13A. Okay. Have a look at it. See what's going on. Get myself almost ready, I think. A few seconds. There should be more people here, but it is what it is. I'm just finding where 13A is. Here we go. Yep, I see it. Let's do a score review.
I have a question.
Cheers, Hannah.
I might need to leave a little early. Do you post these lectures on the webpage?
Yes.
On the canvas?
Yes, you probably won't see them until, yeah, on Canvas. You probably won't see them until tomorrow. It takes a bit of data process,
Okay,
everything.
where is there a certain
Um,
tab I should look for them under?
Yeah, it's got that, oh God, what's its full title? You'll find it under, I'm going there right now so I can tell you what I
Okay.
called it. It's under Math 146, Class Zoom Schedule and Videos of
Oh
Class
yeah,
Zoom
I
Lectures.
just found that.
And when
I
you
put a
click
link in
on
the
it,
chat
there's
for it.
lots of tabs. Yeah, and you just click on the tab, week, this is week 10, so week 10 tab and you'll
Alrighty,
find
thank.
them. But it's got all the other 9
Okay.
weeks as well.
Yeah, I might need to go watch a few before I do the final too. Thank
Okay,
you.
well, I think I edited out most of my jokes, so it won't be anywhere near as funny as it should be.
That's
Question number 6. Let's see if I can get that one. Just getting it set so when we do start, we're ready. Question 6 doesn't have a number. You just use salt and then you reject it or you don't. So I'm not sure I've got your right question. Is it 13A, question 6?
Yes, it
Is that
was.
the one?
It's the one where it says use
No.
technology to find the p-value, and then it you enter the p-value, and then it also asks if it's the correct looking graph. And every time I entered it on Salt, it would show the exact graph that I would pick and it would be right. But then when I would enter the number that it gave me, it was not right. For that.
Good. Come on. I don't know what's going on with that one. That one sounds like if you got time at the end, I'll look that up and we'll just play about with it and see if we can see what the issue is.
Okay.
Because the fact that you're getting the right picture but the wrong numbers a bit weird. If you got the wrong picture, then it maybe it was something you did wrong. I don't know. It's a short answer. Well, good afternoon, everyone. I'm going to start with an issue that is kind of just there and okay, Zoom's just going to be Zoom today. Yeah. Try it again. Gotcha. Okay. So we're going to look at the questions that were involved when you were doing hypothesis testing for the difference between two proportions. And we're going to look at this pooled data issue. And I'm going to give you an example and work through it the way that the textbook was expecting us to do it and show you what the correct answer should then look like. And it worked out fine, at least in the 2 examples I did. So I'm pretty comfortable I know that part of it. What I have done to make your life a little bit easier and fairer because of the way WebAssign is doing those questions is I just made those questions worth 0 points. So the net effect is that you're doing them to get practice at doing them. Will you pretend that those questions are unpulled, right? Just the usual way that I described how to do them. Because in my opinion, that's a much more realistic way. And that way you're getting practice at doing them that way. But I want to show you, because I think you would like to know what on earth was going on. So I'll make up a story. Let's have self-identified males and self-identified females. And we collected 2 samples, and it was 100 males and say 250 females. And we asked them, what did we ask them? Have you ever speeded? Right? Have you ever been given a speeding ticket? Which basically means you've been caught speeding. And in the men's case, it was 60 out of 100. And in the female's case, out of the 250, it was 110. So in this case, it was 0.6. And in the second case, it was 130 divided by 250, and it ends up being 52. And we were being asked in this question to set up a hypothesis test that males get more speeding tickets than females. So, is this enough evidence to prove that males, I guess, go faster than they should compared to the females? And P1 is the males, right? P2 is the females. The null hypothesis is that. I did show you, didn't I show you how you, I believe I remember showing you how to do the subscripts in WebAssign. Because if you just call it P1, it says you're wrong. So you have to do that funny P subscript thing. And in this case, it's going to be that, is there enough evidence that P is bigger, P1 is bigger than P2, which becomes is the difference greater than 0. And nothing really strange has happened yet. This is where the problem happened. The formula that I would expect you to use in a test, and I'm putting this one in for completeness sake, is that the two groups are independent of each other, and whatever one does has no effect on the other, which is why I like that standard error. Would you agree that in many situations, you can't really make the assumption that the two groups are similar enough that you could just pull the data? I'm pushing that argument and I'm still agreeing with myself. But that's not the one they were using. In the later, I think it's the last 3 or 4 questions from that section, they were pulling the data. And not only were they pulling the data, they were using a very specific version of that pulled data. So let's show you first part. You don't have a P1 and a P hat separate. You have a single P. And you get that by adding the number of people who speeded. So that's the males and the females. And it's over the total number of males plus the 250 females. So that ends up being 190 out of 350. And we've talked about that before, so this is not new. It's 190 divided by 350. And this comes out to be roughly 0.543. And the standard error for the difference between the two uses a pooled pooled standard deviation formula. And it's P. I'll call it 1 minus P hat. It's really Q, but I'm just being awkward here. Now, you would normally expect this, and that's where I went wrong, that you would just divide this by the total sample size, which is 350. And that is definitely one version of that answer. Now, this is not going to be correct either. That shows you why I was having so many problems. It is P hat, which is what, 0.543 over 0.457 divided by a total of 350. And I thought, and I was mistaken, that that was the standard deviation that they were using. But after I went and looked at it, I found out they were using this version. So this is the yes version. P1, one takeaway P1. With that guy. That's just an adaptation, right? That's another way of finding the standard error for the difference between two proportions. Now look at it. It's got the p and the p hat, just as I had, but you don't divide by the total. You multiply by this guy. So in the question I've just set up here then, you're going to have the square root of p hat, which is 543, q hat, which is being called this right now, 0.57. A 1 over 100 plus a 1 over a 250. And that is replacing the over 350 guy. Now, although that is pretty ugly, you can actually still calculate it in one go. So it's the square root of 0.543 times 0.457 times a bracket 1 divided by 100 plus 1 divided by 250, close the brackets, and you get, out of all that hard work, a 0.059. And then you get your test statistic, and it's a z-score, and it is p1 hat take away p2 hat over the standard error. And no matter what version of standard error I used, this formula is the same formula. So it doesn't change. All that changes is how you calculate this guy. Now, in the story I've got, this guy is 0.60, this guy is 0.52, and the standard error that I got was 0.059. And that I can do again on my calculator, so I'll go bracket 0.6, take away 0.52, close brackets, divided by 0.059, and that comes out in my case to be 1.356. And that guy is what they're calling the test statistic. And your p-value is the way it always was, and your conclusion is the way it always was. They have this rather ugly looking adaptation of the pooled standard standard error formula. And that's where it was going wonky. Now, the fact that when I used what I believe was going to be this version, which is also an acceptable version of that, sometimes this number and this number were so close that you got the answer right anyway. Now you might think, how can that be the case? Well, let's just show you. If you take something and you divide it by 350, or you take the same something and you multiply it by 1 over 100 plus 1 over 250, what you're really saying is that this fraction is going to hopefully be almost the same number as this fraction. And sometimes it is. And sometimes it's a little bit further away. Yes.
Yona's in the waiting room.
Oh, thank you. Gotcha. So let's just check that one out. 1 divided by 350 is 0.002857. And if you take the two separate fractions, 100 and add a 250th, you get the answer 0.014. Can you see in this case, quite a significant difference? In other combinations, there's not an awful lot of difference. Right? It just depends on how these numbers are split and how big they are. So that was essentially your pooled data issue. So let's tell you the good news. Good news is none of your final exams are going to be using that formula. All exams are going to be using, if you get a question, will be this one. Secondly, I went into the section where they did these questions and I changed the points. I made the last 3 questions, I think it was, 0 points. And then I just got to WebAssign to rescore them accordingly. So the net effect is that you won't have lost any points out of those questions. Now, if you haven't got to those questions, I strongly suggest that you use them not to try and get their answer. Don't worry about your answer not matching. I mean, if you want to do it this way, that's fine. But I would prefer that you used it to practice doing the questions using this standard error formula, because that's the one that I'm going to actually be using in your final exam. Okay, any questions about that? I hope I've kind of made things a little bit clearer for you for why certain questions weren't working. It wasn't that we were doing anything significantly wrong. We were just using a different formula for the standard error than the one WebAssign had. And I'm kind of annoyed at WebAssign. Shouldn't they have at least said something like used pool data, or even better, use pool data with this formula? If they had said that, wouldn't the question have caused a lot less hassle to you, because at least you'd know what the numbers you should be using were and what formula you should be using to get those numbers. Okay. Next thing I want to do, and then after that we'll make it very open-ended, is I want to show you how to calculate what you need to get in the final. So it's going to be a little bit messy, and it's going to involve you having to use your calculator. So first thing you're going to have to do is find your last report. And in your last report, you will be given a percentage. Let's say that your percentage is 85. So does everybody here know what their percentage is if you want to do this?
Yep.
Okay. So if you've got your percentage, I'll give you a minute to go hunting for it. It was sent to you, God, was that about a week and a half ago?
I think I got
like
one
a week ago
yesterday
anyway.
too, like another copy or
Oh,
something.
oh, good. I didn't know if I'd done that. I'm glad I did. I forgot. So there's another one yesterday. All you want to find is that guy. Now, I'm making a couple of assumptions here that may not be true. I am basing that percentage as what you would get after test 5 and what you would get after you've done all your participation and all that stuff. Now, if you do well in test 5, that will go up. If you do badly in test 5, that will stay put, because I always throw away the worst test. Make sure that you do all your homework assignments so that those grades at least stay put, if not get a little bit better. And hopefully that you stay to the end of this week and you get all the participation, in which case it could be. So I'm making an assumption that everybody here, it's going to be that number or something bigger. So that's like the worst case scenario. Now it gets a little bit messy. First thing you're going to do is you're going to find 70% of, oops, not 70%, you're going to find 85% of 700 points. So in my calculator, that's the same thing as going 0.85 times 700. So 0.85 times 700. So what you've got now for this person is 595 points. And I'm going to call that your raw score. Right, so you've all got your raw score right now, whatever that might be. So here's a little table. And in here, we're going to show you what you need to pass. which is a 2.0. What you need to get 2.5, a 3, 3.5, and for some of you, you're going for glory, right? You're going for a 4.0. Now, to get a 2.0, you will need to get what I'm calling a total score. That means after you've done the final, right, of 750 points. 800 gets you that. 850 gets you that. 900 gets you that. And 950 points gets you that. So now we're going to get what you need to get in the final. You take your raw score and subtract it from that. So this person needs 750. Take away the raw score, and that's 155 points. So you will need to get 155 in the final. By the way, the final's got 300 points. So what's that, about 52%? I think if that was you, you could fail, but I think you should be pretty confident that you're going to get some kind of passing grade. Now, if you want this fella, you're going to have to get 205 points, which is about 68, 69%. In this one, you'll need 255 points. That's about 85%. That's quite high. It's quite hard to do. If you want this one, and if you want this one. So for this person, they are not going to be able to get a 3.5. They could get a 3.4 if they did really well in the final, right? But that would be as good as that's going to get with their particular raw score of 85%. Now, bear in mind, I've also said, look, that's assuming this. Maybe you'll do a real great test 5 and this will change, right? Maybe it'll
also
go up
not
to
counting
90%.
the spaces between them. So it's not like if you can't reach a 3, or I mean, if you can't reach a 3.5, that doesn't mean you're getting a 3. You could get more than that, right?
Yeah, you could get 3.4, right? Yeah. Every 10 points counts as a 0.1 on your scale. So if you wanted to know what a 3.4 was, it would be 295 in the final. Now, 2.0 is technically a pass, but because this is a terminal math class, there is another grade called a 0.7. Does anybody know what a 0.7 counts for? It counts as a passing grade for a terminal class. In other words, if it's the last class in the sequence and it's the box that you need to tick, in this case, this is your numerical box, you can do a 0.7. So a 0.7 is a special score, which I'm now going to tell you what that is, because I have to make sure I do it correctly. You only need 620 points. So
That's
this person
probably
here,
not all that great for your GPA, though.
it will kill your GPA, but you will at least pass. And for some of you, you need to pass, right? You need to get your EE and get out of here, right? And so that will do a ding to your GPA, but at least it gets you out of the, the college boxes that for numerical. Okay, any questions about that particular thing? How to calculate your grade? You all understand how you're going to do it? Find your raw score and then do this table calculation. These numbers here were for that person. Obviously, if you got a 90%, these would be smaller. And if you had a 70%, these would be bigger. Are we good? Has anybody got a topic then? Let's make it open-ended. Would you want me to go over for the last 20 minutes? Any issues? That is scary. Oh,
Could
good.
you
Would you
go
go,
over
Megan?
how to do a stem and leaf diagram again? I'm really lost on that.
Stem and
there-
leaves. Yes.
Yeah.
Okay. Are you comfortable about how you get what's called the 5-figure summary from data, and it's a drawing it afterwards, or do you need to see from start
I
to
just need
finish?
the drawing because I can do the
Okay.
five-figure thing.
Okay,
Yeah.
so let's suppose that we did a 5-figure summary and the numbers came out like this. The median is also called Q2 in some situations. Okay, so you got your 5-figures summary and you want to do one of those, oh, wait a minute, stem and leaf. I'm doing a box plot. Well, oh, okay, let me finish this one, then I'll do a stem and leaf. Oh, God, I'm getting old. Or maybe you meant a stem and leaf after all, in which case it wouldn't be so bad. So the smallest is 30 and the biggest number is 90. I could certainly go all the way to 100, you know, and start at 0 if I wanted to as well, right? So you go 30, you go 40, 50, 60, 70, 80, 90, and you do a scale. And you make sure the scale is equal. It's probably only going to be 20. And the way you draw the picture is the minimum is 30. So you do a little mark there at 30. The maximum is 90. You do a little guy there. And then Q1, you do a longer line. 34 is probably about here. And the median is 51, is probably about here. And Q3 is 60. I'm much more comfortable about it being here. You join these guys up. Whoops. And then you join these guys up. And that's called a box plot. But you were asking about a specific thing called the stem and leaf. So is that what you wanted, or do you were looking for a stem and leaf? Celia?
Oh,
you want
right.
me
Sorry.
to show you
Yeah.
this? Yeah.
Yeah.
Okay. Right. So I'm just randomly going to put some numbers in because this is kind of how these things work. Takes me more time to write the numbers than it will do the question. But I do need enough numbers to kind of work with. Right, let's suppose I've got a set of data and I want to create a stem and leaf for this data. So you scan around and you need to kind of know where to start. So the smallest is 7. And you need to know where to finish. And I believe the biggest number I've got is 63. So what you do with a stem and leaf is you
71
draw,
next to the 63.
oh, right beside it, thank you, 71. Lucky enough that I would have been able to fix that later, thank goodness. And so you have a basic shape that's called the stem. And on this stem, you're going to go 0, 1, 2, 3, 4, 5, 6, 7. And the stem is going to represent tens in this case. And then That's the stem part. And the bit they call the leaf are the single digits that go next to them. So you start off, this is the first pass through. This isn't the final answer, but it's pretty close to the final answer. 14, 21, 35, 41, 37, 7, 11, 17, 31, 41, 21, 31, 42, 51, 63, 71, 32, 41, 43, 17, and finally finishing with 12. Now, the reason that isn't the total answer is that a stem and leaf should be in order. So I'm just going to put my stem back in. And this is, I'll make it red. The final answer is 7. That represents 14. That represents an 11. These are two 17s and a 12. So you go a 1, a 2, a 4, and two 7s. You see what I mean by in order? Then you go to the next one. So what's it going to be? 1 and 1. And then it's 1, 1, 2, 5, and 7. And then it's 1, 1, 1, 2, and 3. Then it's a 1, then it's a 3, and then it's a 1. And to finish a stem and leaf, you should always put a key. And what that means is you just randomly pick one, something like 3/5, and you tell people that that means 35. And the reason for that is that you can do a stem and leaf for decimals. Can you imagine these were 1.4, 2.1, 4.1? If that was the case, then my key 3/5 would mean 3.5. But in another set of data, couldn't this be 140, 210, 410? And in that case, wouldn't 3/5 mean 350? You see how the key is important so that people can tell what this data is representing, right? What kind of values is it representing? Now, one of the cool things about a stem and leaf is that it's relatively quite quick to do as long as there's not hundreds of numbers, right? You wouldn't do it with hundreds, but if it's a small data set, you can do it. Also, you can do this. If you turn it on its side, don't you get a very rough idea of what the histogram of the data would look like? You see, kind of, and that might allow you to tell whether your data is symmetric, bell-shaped, skewed left, or skewed right. Because if you're going to do some of the things that we do later, like the student T distribution or Z scores and things like that, don't we make an assumption that the data is at least roughly bell-shaped?
Right.
Well, if you collect a whole load of data and you draw one of these and it looks totally non-symmetrical, right? It's skewed to the left like nobody's business, right? Or is this data here has probably got two distinct hills. As you can see, this data looks like there's two hills in it. That would be a set of data where you would be very skeptical about trying to do Z scores or T distributions or hypothesis tests or any of the things that we've been doing. And mostly because your sample of data doesn't reflect very symmetric looking data. And you're allowed a lot of flexibility. It doesn't need to be perfect. It just doesn't need to look horrible, right? As long as it's not totally weird looking, you can probably get away with it because it's pretty resilient, Z scores and T distributions. They're pretty resilient. But I'm looking at that set of data. Maybe I'm a bit tough. Would you agree if there were a couple of more 20s, that wouldn't look quite as bad? So maybe I was being a bit cruel there. I mean, if only a couple of numbers would fix it, I probably would go with it. You know, I would use mean, standard deviation, you know, do 90% confidence intervals. You know, I could probably get away with it. That's a good question. Actually, I got to do 2 questions, even though you only asked 1. Okay. Anything else that you would like? Anybody?
I realized after you started explaining it that I mixed up stem and leaf plot or diagram with the probability tree diagram. I mean, it was still helpful because I
Probability tree.
realized I
Okay.
didn't understand it, but I meant the probability tree.
I don't think that's a bad thing. I think that's probably helped people. Any question you ask, some of you are going to say, "Yeah, I forgot about that damn thing. I've only seen 2 of them. I wondered how, you know, I can't remember how they were made," or that one. So I don't think we've lost anything by doing this. I need a story for a probability tree, so here goes. I'm going to have a bag, and in this bag, there are 4 green beads and only 4 red beads and only 3 green beads, right? And it's going to be pulling beads out of bags. Now, there are 2 versions that you have to be careful about because they generate different probability trees. And they typically are called with replacement. And the second situation almost sounds the same, but it's called without replacement. So in this story, you're going to take 2 beads out of the bag. Do you want to do a with replacement story or a without replacement story? Which one shall I do first? Because I'm actually going to do both to show you the difference. With replacement or without replacement? Which one do you want?
With.
Okay. So what that means is you stick your hand in, you pick out a bead, you look at its color, and then you put it back in the bag. In other words, the bag always has 4 red and 3 green in it. Right? And we're taking a 2 bead story, right? We're doing this twice, and we're going to create a probability tree for what that would look like. So the first bead could be red or it could be green. Now, what's the chances that I pick a bead out of this bag and it's red? And the answer is what? 4 out of 7. And what's the chance it's green? It's 3 out of 7. So you write the probabilities on the road that leads to it. And then you do a second situation. And the second bead could be red or green again. Have you noticed that as you build the tree, you double the number of little branches, you know, because that's just the way the story is going. Now, since you're putting the bead back in the bag, when you come to take the second one out, isn't there still 4 red and 3 green? So it's still going to be 4 7ths and 3 7ths and 4 7ths and 3 7ths. And I've kept these guys as fractions because they're ugly fractions, but it's not uncommon to use decimals as well. So you might have 0.2 and 0.8, you know, things like that. Now, at the end of these trees, there are 4 destinations. And so we find the probability of, say, this combination. This particular combination would be both of them are red. And you find the probability, I think I'll use red, by multiplying the pathway. So 4 7ths of the time this happens, 4 7ths of the time this happens, that ends up being 16 out of 49. On the other hand, this one here, won't that be 4 7ths for a red? And goodness gracious me, nobody noticed my mistake. Red and green, right? So 4 7ths is red, and then you multiply 4 7ths by 3 7ths. And you get the answer that the chances that happened is 12 out of 49. But I won't do colour scheme, I'll just go for it. This one is 3 7ths followed by a 4 7ths, which is also 12 out of 49, and 3 7ths and another 3 7ths, and that ends up being 9 out of 49. These guys here are very often the guys that you're going to be able to use to answer questions like this. What's the probability that both of them were red? Well, you look at the story and you say red and red is this guy. And so the answer is 16 out of 49, and you can turn that into a decimal if you like. But they might ask, what's the probability that they were different? Well, isn't that another way of saying a red and a green, or a green and a red? And since there's two ways that can happen, don't you just add those two together? And in that case, you would get 24 out of 49. And you could do weirder questions like, what's the probability that none of them are red? You know, so they might, tuck that in. And that is a probability tree. And there are two examples of how you could use it to do it. I've seen ones, haven't you, where you had to do it to 3. Isn't it normally boy, girl, boy, girl, boy, girl? Remember the questions to do with 3 children in the family kind of thing? Now, when it was 3 children in the family, it was a without replacement, right? If you got a girl, you could still get a girl without any change, right? It's a half all the way through. Now let's do a with replacement.
Doesn't the probability
Without
have to
replacement.
add to 49?
Say that again.
Doesn't the probability have to add to the denominator 49? Because it would be 50 over 49 because that's 16 and 24.
Oh,
yeah?
let me check. I hope I haven't done this wrong. 16, 28, 40, 49. Not they add up to 49 over 49. If that's what you're asking.
No, I meant like the bottom ones, the probability of them both being red and them being different. Wouldn't that add up to 49 out of 49 or no?
No, because you could get to 2 green. So you'd be shy of one.
Okay.
So you could have a red and a green. Well, the first one coming out isn't actually any different. It's still 4 out of 7 and 3 out of 7. Now, when you don't do replacement, right, without replacement, these guys do change. Right, let's do this one here. The first one came out the bag was red. You see that my bag now has 3 red and 3 green in it. So the chances that I get a red one has now altered. It's 3 out of 6. And the chances that I get a green one has now altered. It's also 3 out of 6. Now, look at the difference. You see it was 4, 7, 3, 7. Do you see it's now changed? Right, suppose we look at this one. That means a green one. Yes.
Sorry, it's Nakia.
Sorry, Nakia.
I cannot get that. I think every question we do when the number alters, I just don't understand it.
Okay, let's do it visually. Imagine that you're taking 2 beads out of this bag, right? And you're not going to replace them. And this one means that you've taken a red one out. So the first bead, right? You've taken a red one out. So there it is. This bag has now changed. Because you have taken a red bead out of the bag and you haven't replaced it, isn't that what the bag looks like now? Now, on this bag, you're going to take another bead out, a second bead, and it's going to be red again. So the second bead is going to be red. What's the probability of picking a red bead out of this bag?
Three out of 6.
That's where that's coming from.
Another way of thinking about it is the top number is the number of the balls we're interested in. and the bottom number is the total number of balls. So to start, there's 4 red ones in there, and there are 7 total. So that's 4 to 7. And then when you pull one out, there are only 3 red balls left and 6 total balls left. So 3 over 6.
And they tell you that in the problem, right? That
It'll say
you're-
without replacement.
They say in this, yeah, they say in the story without replacement.
Oh,
That's the key word. You should look for it,
okay.
right? Without
That
replacement.
just totally passed
Right.
me. Okay. That's what I
Okay.
missed. Thank you.
Okay, that's all. Sometimes that's all it takes. Right, let's go for this one. These bags aren't going to work for this new story because the first one was green. So if I cover up that green one, do you see that there's 6 beads? But do you notice that the combination is a 4 red and a 2 green? You see that one? 4 red and 2 green. So what's the chances that you pick a red now? Well, there's 4 out of 6. So 4 out of 6. And what's the chances then that you get a green one? Well, only 2 out of 6. And do you notice that when you look at a pair, there's still 6, 3 and 3, and 4 and 2. Can you see it's basically telling you what your picture looks like? Are we comfortable with if the first one's a green, 4 out of 6 red, and then 2 out of 6 for green? Good. Yeah, different backstory. Now, the destinations, these guys here, 4 7s times 3 6. And that gives me 12 out of 42. 4 7s and 3 6. 12 out of 42. Oh, come on. There's something not quite right here. 12 out of 42. That's just a flick of numbers, right? At least the last one's not the same thing. It's 6 out of 42. And if you want to do a quick check, shouldn't these 4 things add up to 1? So you should add up to 42 42s. Now, from this diagram, if I now go back to this question, what's the probability that they're both red? Red and red, 12 out of 42. You see that the answer is different, quite significantly different, isn't it? Different fraction. What's the chances that they're different? Well, the different are these two. And so that ends up being 24 out of 42. And you could use this tree diagram for, none of them are green. If you did a 3, could you imagine I did a 3 bead one? It'd be horrendously big, but I could do a 3 bead one, couldn't I? In which case I could then do, what's the probability that they're all red, that there's more red than green that you pick out of the 3, any kind of combination. It ends up being some of these guys, one or more of these guys added up.